Hello everybody. So we are here in this series where we are looking at how we can use mathematics for artificial intelligence and machine learning. So in this video we are going to learn about why a perceptron cannot learn XOR, right? So what is XOR? XOR is exclusive OR gate, right? So let us just see, because this is important, that a perceptron is not a single perceptron. You cannot just work with a single perceptron because a single perceptron has less capabilities. For example, the simple task like learning XOR gate is not possible for a perceptron. So we will look in this video why perceptron cannot learn XOR gate, and it's very simple, right? So first of all, we should know what is an XOR gate. So what is an XOR gate? It is a gate which invites two inputs and the output is a single value. When both the inputs are false, okay, then output has to be false, and when both the inputs are true, then also the output has to be false. That's why it is called exclusive OR. That means only one of the two inputs should be true, then only you will get a true output. So if it is 0 1, you get a 1. If it is 1 0, then also you get a 1. And for the other two cases, for 0 0 and 1 1, you get a 0, right? So this is the XOR gate. So now we will see how perceptron works and how we can try to make it learn XOR and then it resists, right? So what is a perceptron? A perceptron add all the perceptron, here is a perceptron. So what does perceptron do? It add all the inputs, weighted inputs. For example, if I have the input x1, x2, xn, and this is my bias term 1. So these are my weights, w0, w1, w2, wn are my weights. So what the perceptron does is, it will take the weighted sum, right? So it means that it will do 1 into w0, x1 into w1, x2 into w2, xn into wn, and then it will pass it through a step function, right? So what is a step function? Step function is something like this. This step function is like this. It will be having a value 1, right? It will have a value 1 if your input is greater than some threshold epsilon, and 0 if your input is less than the threshold, right? So here what is happening, for this XOR case, we have only two inputs, right? So we have this situation. This is our perceptron. So this is the weighted sum. Then this is the step function, right? And suppose my threshold is epsilon. I can change this threshold. So what is the meaning that this perceptron has to learn the XOR gate? That means that if I give x1 and x2 as my inputs, it has to learn what should be the weights, so that corresponding to let us just write it as w1 and w2, so it matches with x1 and x2. Okay, so it has to basically learn about what should be the optimal weights, right? So we are saying here, suppose epsilon is your threshold for the step function. So when both x1 and x2 are 1, you want your output to be 1, right? When both x1 and x2 are 1, you want your output to be 1, right? This is what you want. So it means that, let us see how it is passing through the perceptron. x1 into w1, x2 into w2, their sum. x1 into w1 plus x2 into w2 is here. And because x1 and x2 are 1, so we have w1 plus w2. And since we are seeking the output to be 1, so we want that this w1 plus w2 should be, because you want your output to be 0. We want output to be 0, because for 1 1 we want our output to be 0. So we want this w1 plus w2 should be less than threshold, so that the step function kills it. So it means that we want w1 plus w2 less than epsilon. Okay, so this is what we got then, right? And now suppose one of the inputs is 1 and the other one is 0. You can take any one of them as 1 and the other one as 0. Then what will be the value of w1 x1 plus w2 x2? That would be 1 into w1 plus 0 into w2, which is w1. And what output you are seeking here? You want output to be 1, because this is exclusive OR. So output will be 1 only when this W1 here is more than threshold epsilon. So from here you get that epsilon should be less than W1. And similarly you take the other case where you take x1 to be 0 and then you take your x2 to be 1, right? In that case what will happen, your w1 x1 plus w2 x2 would be 0 into w1 plus 1 into w2, that will be w2, and you are seeking output to be 1, so you want w2 to be greater than epsilon. So we get this thing. Now it means that if w is greater than w1 is greater than epsilon, w2 is greater than epsilon, then for sure w1 plus w2 is greater than epsilon. But we already got that w1 plus w2 is less than epsilon. So we reach at a contradiction. So it means that you are getting, a system of inequalities which they don't have anything in common, right? So it means that you will never get these w1 and w2s such that corresponding to 1 comma 1 you have 0 output, and corresponding to 1 comma 0 or 0 comma 1 you have 1 output. It means that a perceptron can never learn a simple thing like XOR, right? So what this tells you? This tells you that perceptron alone are not sufficient for doing tasks which we are seeking, right? With the neural networks we want to do complex things, so it is not even learning the perceptron is not even learning the XOR gate. That is why we will be working on a combination of perceptrons. Thank you. Okay, please share this video and subscribe to this channel. Bye.